Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Deflection caused by temperature changes, problem number 2. Hello friends, today now we are starting a problem number 2 on deflection caused by temperature changes. We have done with this problem number 1. Now let's see in details in problem number 2. What's the problem is here? So let's see in details. Now see, this is a question number 2 given over here friends. For a rigid jointed frame subjected to temperature variations as shown in figure, find the horizontal deflection at D full stop. Assume alpha is equal to 12 into 10 raised to minus 6 degrees Celsius per degree Celsius and depth of all members is 400 mm. Full stop. Neglect the effect of axial deformation. Always see this. Neglect the effect of axial deformation. We do not have to take the n bar. Okay. Now let's start with the solution. This is a question given to us. 20 degree to 30 degree, 15 to 25 and 30 to 15. This is 3 meter. This one is 4 meter. This one is 5 meter. Now see, just apply the solution. Now just start with this solution. Now what's the solution will say us? To find now friends, now when you are starting the solutions, now to first you have to write to find horizontal deflection at D, apply dummy force, dummy or fictitious force P is equal to 1 kilonewton horizontal towards the right, horizontal towards the right. We don't know the direction, to always assume the outside. Okay, so we have horizontal towards the right. Now let's draw the diagram once again. Now see what we have to do. Now we have to apply 1 kilonewton at D from horizontal towards the right, like this. This will be 1 kilonewton. Okay, now here, now see, here will become 3 reactions since it is a fixed. See the questions here, it is a fixed one. That's why we have to take here as three forces. Okay, so it will come, first one will be, this is A, B, C and D. This is your VA and CH is in this direction. This is your HA, and we have applied also one moment also like this. This is nothing but MA. Okay, now we have to solve these all values to using condition of equilibrium. So applying condition of equilibrium, find reaction. Okay, now how you have to find reaction? See, taking moment at A equal to 0 clockwise positive. So what are the values will come? Now see, we are taking moment at A. So what will become? See, the distance will be 5 meter, this will be 4 meter and this will be 3 meter. Means this is 3 meter, this will remaining will be 2 meter over here. So we have to write, see, we are taking moment over here, take a rod and fix at A, and just see this 1 kilonewton is going in this direction, means this is clockwise. So 1 into this distance is nothing but 2 force into that perpendicular distance still here. Okay, so this will come 1 into 2. After that, see, this is anti-clockwise. So minus MA is equal to 0. Your MA will be 2 kilonewton meter. Okay, MA will be 2 kilonewton meter over here. Now see, now this we got the value will be positive, means our assumptions of this direction is correct in this part. Okay, so no need to change the direction. In previous question number 1, we will change the direction because the answer will become in minus. So when the answer will come in minus, always change the direction in clockwise also or in vertical and horizontal forces also. Okay, now after that, this will done. After that, summation Fy equal to 0 upward positive. Okay, now see, this Va is going upward and this downward there is no load, so plus 0 equal to 0, therefore Va will be 0 directly. Okay, you can write directly Va will be 0 because there is no vertical forces. Now after that, summation Fx is equal to 0. Summation Fx equal to 0, this as positive. Now see, this HA will going in this direction minus HA, this HA will going in this direction plus HA is equal to 0. Sorry, this is not HA, this is plus 1. So your HA will be 1 kilonewton. Okay, now means this value will be 1 kilonewton. As a diagram seen, this is going in this direction means 1, and this will going in this direction is nothing but 1 kilonewton. It's quite simple. Now we have done with this first part. This is a find reaction. Now after that we have to write one statement. The statement will be, statement I am writing over here, forget axial force N bar and bending moment M bar diagram, because after that we are drawing the shear force, bending moment and axial force diagram part of each members and different. Now let's start with the first take AB part, then BC part, then CD part, and draw the AFD and BMD. No need to draw the SFD because we have to find the area also. Okay, now after that, consider part, first of all consider part AB. Consider part AB. Now draw the FBD of AB part. Draw the diagram of AB part first. One kilonewton, this is A and this is B. No need to draw the couple. Always remember friends, no need to disturb the couples. Okay, because when we are drawing the bending moment diagrams, always see the original diagram and you can get the answer. No need to draw couple over here. It will get mistake to you. Okay, so don't do this. Now see, now we have to see the part A and balance the part C. See, this 1 is kilonewton from right to left. To balance this, we have to apply 1 kilonewton from left to right over here at B. Now this will come 1 kilonewton. Now see, this part is your balance. This is 5 meter. Now this part will be balanced. After that, extend this part. Extend this part and draw the AFD. Now since there is no axial force diagram, therefore AFD will be 0. This is A and this one is B. Your AFD will be 0, comes over here. Okay, AFD will be 0. After that, now draw the bending moment diagram. To draw the bending moment diagram, I am repeating again and again and again. To draw the bending moment diagram, always see the original figure. Always see the original figure. Now this is your original figure. Now we have to find bending moment. I am writing over here bending moment calculation. Now what is the sign convention? See, this will go, this is positive. Okay, this will go in negative. Sagging positive, hogging negative. Now see friends, we have to follow this sign convention. Sagging positive, hogging negative. Now we have to find, this is your A, this is your B. Now we have to find a bending moment at A. Always see the original. See, this is the original diagram. We have to find bending moment at A equal to. Now see, as you are standing inside the frame, always assume that you are standing inside the frame. Now you are seeing from here. You part A, B, you are seeing from here like this. You are not seeing from here, because when we are seeing at here, now we are taking bending moment at A, either we are taking this whole part, either we are taking this part left side, or this right side whole part, both will get same. Now see this will going hogging, not in sagging direction, because when we are taking see put over, write it, put over like this, and see take a section over here. Now see this is going in this direction, means it will go sagging, so it will come minus, this directly come -2 over here. Or either you can take this side, if you are taking this side, this is also get minus, so 1 into this distance will be 2, this is also get 2. You are taking from both the side, answer will be get same. Now see, if you are not assuming you are standing in the inside the frame, to AB part you are seeing from here, this will get positive. When we are seeing from inside, it is hogging. When we are seeing from outside, this is sagging. So always remember, always see you are standing inside the frame. Okay. Now let's see, this will come -2 kilonewton meter. Now bending moment at B equal to, always see the original diagram, we had cut a section at B, either you can consider AB part or you can consider BCD. We are considering AB part only. Now see, we are taking section over here and we are seeing from this side, so this will come -2. After that, now see this HA will in this direction, means this will be sagging, so -2 plus 1 into this distance is 5. So 1 into 5 minus 2, this will come 5 minus 2 is nothing but 3. Your bending moment at B will be 3 kilonewton meter. Okay friends, now this will be -2 kilonewton meter, this is 3 kilonewton meter. Now draw the diagram. A will be -2 and B will be -3, sorry, +3. Okay, now this is minus, this one is plus, this is 3 kilonewton meter, and this one is 2 kilonewton meter. Now this is done with this bending moment diagram over here. Okay, now let's move on to second part. Now second part will be consider part B and C. Consider part B and C. Okay, now draw the FBD of BC part. This is B and this is C. Now see, you can take this member, you can take this diagram to balance X and Y direction. See, this one is 1 kilonewton is going in left to right. So to balance this, we have to write right to left 1 kilonewton over here also. Okay, now while seeing B, we have to balance the part C. So this will going in this direction, so this will also go in this direction, means this is also a 1 kilonewton and this one is also 1 kilonewton. Okay, now after that, no need to draw the couple. Now extend this all and draw the AFD and BMD. Now see, the sign will indicates it's a compression or tension. This is a tension. Tension means we have taken positive or positive sign you have to draw inside the frame. This is the tension, so we have to draw inside the frame like this. Positive means inside the frame. This is your B part, this is C part. This is 1 kilonewton, this one is also 1 kilonewton over here. This is your axial force diagram. Okay, now let's move on to bending moment diagram. Always remember, when you are drawing the diagram, if plus is there, means you have to draw inside the frame. If minus will come, you have to draw outside the frame. Okay, now after that, B and C. No need to calculate the bending moment again and again, because at bending moment we are seeing the original diagram. See, bending moment at B will be 3 plus 3 kilonewton. Okay, bending moment at B will be plus 3 kilonewton. No need to find again bending moment at D. I am not explaining now again and again this sign convention. You can follow. Bending moment at B will be 3 kilonewton. This value I have already find out. Now we are finding bending moment at C is equal to. Now see the original diagram. Now we have to find the bending moment at C. Either we can take this part, this whole part, either we can take this part. We are taking now this part. Now see, you are standing from here and you are taking section over here. This will go sagging. So it will come 1 into 3 positive. So this will come 1 into 3 is equal to 3 kilonewton meter. This is also 3. Now see, both are positive, means you have to draw inside the frame. Three kilonewton meter. This is also a positive. This is your bending moment diagram. Okay. Now we have done with the axial force diagram and bending moment diagram. Now let's start with the third part. Will be consider part CD. Now when we are considering part CD, now balance. Now draw the FBD first like this. Now see, this is the FBD part. Now see. Now no need to show this diagram. If this is what this one is going in this direction, you have to draw the entire direction. Either you can directly take the C part, loading of C part and balance while D part, and while seeing the D, balance the part C. Now see, this one is going in this direction. It's quite simple, friends. This is also a 1 kilonewton. Okay. Now after that, extend all the part and draw the AFD and a BMD. No need to, I am repeating again and again, please do not consider couple in here this beam, because it will get complicated to you. Directly see the original diagram and draw it, and this will correct. Okay. Now since there is no axial force diagram, therefore its AFD will be get 0. Okay. Now let's start with the bending moment first. The bending moment diagram. Now see, as you all have already calculated, bending moment at C will be 3 kilonewton meter positive. So you can directly draw over here. Positive means inside the frame. Now see, this CD part we have get the value of positive 3 kilonewton, means we have to draw inside the frame is like this. So 3 will be come over here and at D will be 0. So this is our 3 kilonewton meter, and this is your bending moment diagram. I hope you understand these videos. Now let's proceed further. The further will be deflection of D considering effect of axial deformation. Now in exam you have if your question you have given neglect the axial deformation or not, we have to axial deformation. Whatever question is given you can solve directly. Okay. Now let's start with the second part solution. Means second one will be now deflection at D. Now we have to find deflection at D. First I am explaining considering effect of axial deformation. Now we are doing neglecting effect of axial deformation. I am explaining both of them, but in question there is asking neglecting effect of axial deformation. Okay, so I am writing over here considering now. First of all, what you have write, see a member AB as you all know your TC will be 20 plus 30 minus 20 upon 2 is equal to 25 degrees Celsius. Now friend, delta T will be 30 minus 20 is equal to 10 degrees Celsius. After that, delta T upon H will be 10 divided by 0.4. This is 400 mm. We have to convert in meter. Will come 25. Okay. Now area. Now please remember. Now see the part AB part. Now this is your AB part. See this AB part, this is distance, as you all knows, this distance is 3 meter and this is 2 meter. Okay, so how will you know this meters? Or you can apply similar triangle, then get the 1 and 2 and 3. Now see this is in minus sign, so you have to write like this: minus half into base will be 2 and height will be 2. After that, now plus, in plus, this is a plus sign, so plus half into base into height, half into 3 into 3. Okay, so it will come is 2.5 meter square. Okay, 2.5 meter square in, okay, 2.5 meter square. Now we get the 2.5. Now see, we got all the values over here, this and this. Now we have forget one thing. One thing is nothing but n bar. N bar is nothing but axial. There is no axial force diagram, that's why it will be get 0. Now member BC. Okay, now member BC. When member BC 15 degrees Celsius to 25 degrees Celsius. Now here TC will be 15 plus 25 minus 15 divided by 2 is equal to 20 degrees Celsius. Delta T upon H will be 20 divided by 0.4 is equal to 25, and delta T will be 25 minus 15 is equal to, oh just wait a minute, this is not a correct one. First we have to find delta T, so it will come 10 degrees Celsius. Now after that, delta T upon H is equal to 10 by 0.4, this will come 25. Okay, this is not correct friends. Okay, this one is correct. After that, n bar will be 1, this is 1 kilonewton since there is an axial force, and area will be base into height, means 3 into 4 is equal to 12 meter square. Okay, since it is an area. Okay, now see part B and C. Now see, this is part B and C. We have to find the area of this part, so base into height, this will 4 meter and height will 3 meter. Okay, now after that, member CD. C will be member CD. Okay, now in member CD 15 degrees Celsius to 30 degrees Celsius. First of all, we have to find TC. 15 plus 30 minus 15 divided by 2 is equal to 22.5 degrees Celsius. Okay, now delta T will be 30 minus 15 is equal to 15 degrees Celsius. Now delta T upon H will be 15 divided by 0.4 is equal to 37.5. Okay, here n bar will be 0 because there is no axial force diagram. Now area will be, since it is a part CD and CD part bending moment diagram in triangle, so area of triangle half into base into height. Your base will be 3 meter, so half into base into height is equal to 4.5 meter square. We have done all this part. Okay, after that we will apply Moore's equations and find deflection at D. Now see, how will you find? Now right over here, using Moore's equation. Now friends, you have remember this formula of using Moore's equation. Formula will be summation Pj into delta J is equal to alpha T summation delta T upon H into A dash plus TC N dash L. If you have given the effect of axial deformation, so we have to neglect this N dash part. Okay, now here we have to find all this part, so this is your formula. Now apply the formula. This P will be 1 kilonewton into, we have to find delta D is equal to deflection at D 12 into 10 raised to minus 6. After that, now see that See all these three members. Now see this AB part, delta T by H will be 25. After that area will be 2.5, means 25 into 2.5. 25 into 2.5 for AB, plus this n bar will be 0, that's why whole term will get 0. After that plus 25 into 2L plus 20 into 1 into 4. See, this TC will be 20 and n bar will be 1 over in second one. In BC part, see this is will 10, this will 25 and area will be 12. So 4 into 20 into 1 into 4, 20 will be TC. This is your TC, 20. After that n bar, n dash will be 1 and L will be 4 length. This 25 into 12 is, this is your 25, this is 25 delta T by H and A will be 12. Okay, so this is a first part and this is a second part. Now plus third part will be, so you can write AB or BC. Now this is a CD part, 37.5 into 4.5. after that it gets 0 plus 0, CD part. Okay, now our final will become, we have to find deflection at D will be 12 into 10 raised to minus 6. This will come 62.5. Solve separate friends. 380 plus 168.75. Your delta D will be 12 into 10 raised to minus 6, 611.25. delta D will be 7.335 into 10 raised to minus 3 meter. So your delta D will be 7.33 mm. Okay, now see, this is our answer, but we have find with the effect of axial deformation. But in question we have asked neglect the axial deformation. At that time what you have to do, write it over here. Number 3 will be deflection at D. In bracket you will write neglecting effect of axial force. We have to neglect the axial force, means we have to neglect this n part. So our formula will come delta D is equal to alpha T into summation delta T upon H into A only. This is only is remaining over us. Okay, so we have find delta D is equal to 12 into 10 raised to minus 6, 62.5 plus 300 plus 168.75. I am directly solving, friends. You can solve, I am directly solving, you can solve by own. Okay, after that delta D will come 12 into 10 raised to minus 6, 531.25. your delta D will be 6.375 into 10 raised to 3 meter, means your delta D will be 6.375 mm. Okay, in this direction. Now this is your final answer. In exam you have only asking this part, you cannot solve this part. This is not a correct, I am just explaining you. We have done with these problems. I hope you understand these videos. Share with your friend, and yes, don't forget to subscribe to Ekeeda channel. Thank you.